Okay, this is the second video for section 3.1, Algebra 2 Trig, talking about solving systems of equations. So one method to do that is graphing, and we will be using this method the least. It essentially boils down to it's kind of an estimation. I'm not real keen on estimating answers when we have methods to find the exact answer. But the idea of graphing to solve a system of equations is, like I mentioned in the first video, you are looking for the intersection. Okay, what is that point, or maybe possibly set of points, where these equations are crossing each other? What points do they have in common? And I use this graph down here. You got these two lines that we're looking at the left here. These two lines are intersecting at this one point. That x and y value is the solution to that system of equations. That's the idea of solving by graphing. So we have a method with our calculator to do that. Our calculators are kind of nice. They'll give us a decent answer. We can draw graphs by hand. Those aren't usually very accurate, and so our answer is probably not going to be very accurate. But it's still a method, so we're going to talk about it. Now, no matter whatever method we're going to be solving, we have some terms here. So we've got these four terms in orange. Please take a second, hit pause to copy these things down. All right, the first one. If a system has at least one solution, then it is called consistent. So if there's an answer, it's a consistent system. Now, there are two types of consistent systems: independent and dependent. All right, it is independent if the system has exactly one solution. If the system has an infinitely many solutions, it is called dependent. All right, so a consistent system means there's an answer, at least one answer. Okay, independent, exactly one solution. Dependent, there's an infinite many solutions. And I'll talk about what that means in a minute. If there are no solutions, that is this last term, inconsistent. There's just no answers to it. There's no x and y values that work in both equations. Okay, so what do these terms mean? What are you looking for in the graphs for these terms? So in this example here on the left, we'll call this graph 1. We have two lines, so whatever the equations are for this is our system of equations. When you graph them, they intersect, okay? Again, the idea of a solution is it's the point that is in common on both lines, or satisfies both equations. So these lines cross. That means there is a solution. So it is consistent. And there is exactly one solution. These are lines. They're not going to curve back around and cross again. So there's exactly one solution. This is independent. Okay. With this one, let me see if I can separate this. No. What we're looking at here, this is two equations, but they are the same. All right. So there's two lines drawn here. They're just one right on top of the other one. That means if I put this point in there, it works on both equations. This point works on both equations. That one. There is an infinitely many number of points that satisfies both equations. So there is a solution. Oops, this is consistent, but there's an infinite many solutions. Okay, these two lines are one on top of another. So there's an infinitely many number of points that satisfy both equations. That's what it means for it to be dependent. And the last terminology, inconsistent. The system does not have a solution. What we're looking at here is parallel lines. Okay, they're not the same line, but they have the same slope. This means there is no intersection point. There are no x and y values that work in both equations. Hence, there's no solution. This one is inconsistent. Okay, that's what the idea of what we're looking at for those terms. Now, hit pause, take a second to copy down these steps. We're going to solve this example in class when everybody has a calculator. So just copy down these steps, and we'll talk about it in class. If you got your own calculator, go ahead, try using these steps for this equation. If not, like I said, wait in class, and I'll see you tomorrow. There is one more video. There's another method that we're going to talk about, so please watch that one.